Hey there, smart monkeys. Welcome to my channel, and if you've been here before, welcome back. Thank you for your continued support. This is my little platform where I turn struggling math students into maths masters. I post videos Tuesdays and Thursdays, so be sure to subscribe and turn on the notification button if you want to know when I post any new videos. In this video, I'm going to be looking at surface area, and this is a nice follow-up video to the previous video that I just posted on perimeter and area. And yeah, in this video, I'm just going to be teaching you all you need to know about surface area, how to sort of interpret exam questions, what units to use, and so on. All right, so let's do this. Okay, so this is the fourth lesson on measurement, and in this lesson we're going to be looking at surface area and then looking at some questions that include packaging. Okay, so let's jump in. I always like to start with making sure that you understand all the definitions and all the terminology. So let's go through that first. Surface area is the area of all the surfaces of a three-dimensional shape added together. So what does that mean? If I look at this square, the surfaces, so I'm only interested in the surfaces and not what's inside the box, because what's inside the box and the space that's inside the box, that is referred to as volume. However, surface area, we're just looking at the area of all the surfaces of a specific shape. So if you look at this square, you will see that this square has got 6 surfaces, right? 1, 2, 3, 4, 5, and then at the bottom 6. So if we want to calculate the surface area of this, we would actually be calculating the surface area of 6 squares, right? And the area of one square is side times side. So if I want to calculate the surface area of this with 6 sides, then that means I will say 6 multiplied by side times side. And now to actually do the surface area for the square, it would then be 6 times. And if one side of this is 2 centimeters, then that means all the dimensions are 2 centimeters, right? So that means that the answer, the surface area of this box will be 6 for the amount of squares there are, multiplied by 2 times 2, which is the area of a square. So altogether, all of these 6 sides, altogether, if I add up the area of each of them and add them together, I'll end up getting 24 centimeters squared. Right, so that gives you an idea of what surface area is. Now, had the question paper said that this was a box with no lid, then to calculate the surface area of that then would mean you would take away one surface, which means you will have 5 times 2 times 2. Okay, so also depending on the scenario will determine how many times or how many squares you actually have there. Okay, now let's have a look at the rectangle. Now again, this is the dimensions of this rectangle, and let's see, how many surfaces does it have? 6 surfaces, right? It's pretty much the same as the square. The only difference is that the surfaces are rectangles. Okay, so you'll have the front and the back rectangle exactly the same. You'll have the bottom and the top rectangle exactly the same. And you have the right and the left rectangle exactly the same, right? So you will end up having, if you were to calculate the surface area of this, I'm going to calculate the surface area of the front part, which is 10 multiplied by 2. This is a rectangle, right? And the area of a rectangle is length times breadth. So I've got 10 multiplied by 5, and I've got 2 of them. So that's why I multiplied by that 2. Again, take note, I'm calculating the areas of all the surfaces. Then I've also got 2 rectangles that is 10 by 2. So this is the bottom and the top one. Okay. And then I've got 2 rectangles that are 5 by 2. Alright, so if the area of a rectangle is length times breadth, then that means to calculate the total surface area of this entire rectangle, I will then just say 2 times 10 times 5 plus 2 times 10 times 2 plus 2 times 5 times 2. Okay, so this triangle, this rectangle is 10 times, is the front and the back. This one is the bottom and the top. And this one is the left and right, right? So that's why each of them get multiplied by 2. So all of that together then gives me 160 centimeters squared. Again, take note from my previous video where I explained the difference between perimeter and area. Area is always in units squared, and that goes the same for surface area. Okay, the only difference between normal area and surface area is that normal area is calculating the area of a two-dimensional shape, so that will be just one square or just one rectangle, and surface area is then looking at the area of a three-dimensional shape. Okay, so that's why we've got a cube and a rectangular prism here. Now, let's have a look at a cylinder. Now, I know a lot of students get very confused when there's questions that have to do with cylinders. So I'm going to go through this very slowly with you. Okay? So if we look at the cylinder, try and think, how many surfaces does the cylinder actually have? Okay? So we definitely know it's got a circle at the top and it's got a circle at the bottom. Right? So there's three surfaces. Circle at the bottom, circle at the top, and then the middle part that binds the two circles together. That gives me three surfaces, right? So it's two circles, and then the middle one, if you unwound it, you would see that it is a rectangle. So this is what it would look like. Okay, so do you see why this part is then the rectangle? So we have the area of a circle is pi times radius squared, and the area of a rectangle is length times breadth. So if I were to find out what the surface area is of this cylinder, I would add two circles together and one rectangle. But now, I want to explain something to you, and I want you to slowly work with me here and listen carefully. So do you see that the rectangle we know is length times breadth, right? So this will be my length, this will be my breadth. If I look at the circle now, you agree that this is 18. This is 18 because this is 18, right? So this is the height. Now this is equal to the circumference of the circle, because if you think about it, this goes right around the circle when it's in this format, when it's actually a cylinder, right? So this entire length around the circle is equal to this entire length there, which means this part is actually the circumference. So if I want to calculate the area of this rectangle, I'm going to say length times breadth, which is circumference times 18. Okay, so let's have a look at when we're actually calculating this total surface area. So again, like I said, we've got two circles, so it's 2 multiplied by pi times radius squared, so that's for the top and the bottom circle, plus length times breadth. Okay, so take note, we're calculating the area of all the surfaces. Now, if we're going to calculate this, it's going to be the area of the circle is going to be 2 times pi, which is 3.142, which is what they'll tell you to use in the exam paper, multiplied by 1 squared. So why is this 1 squared? Where does this 1 come from? Take note, this 2 is the diameter. So half of the diameter is what you use as the radius. So that's where we get that 1 there. Okay? Plus length times breadth, which is this rectangle. So again, this part is for the 2 circles. So it's 2 circles plus length times breadth, which is essentially circumference times breadth. So what is the circumference of a circle? The circumference is 2 times pi times radius, right? So that means we got 2 times pi times radius of the circle. So the circumference, which is just this length here, is then equal to 6.284. Okay, so this is centimeters. Now we can actually calculate the area. So again, this is the area of the 2 circles plus length now is my circumference, length times breadth, which is my 18. So the total surface area of this cylinder is then 232.51 centimeters squared. Okay, so that is how you will reason your way through a total surface area question. Okay, now let's move on to an example. Okay, so this is an exam type question. Okay, so if I'm going to fast through this, I suggest you pause the video, read the question, try and understand it, and even try and answer it before I even get to the answer. Or you can work through it with me and then come back and try and do it on your own. Okay, so the question says, Chepo manufactures cling wrap. Okay, he is investigating the dimensions of the board he would use to wrap the cling wrap around. So if you look, you remember, you know the inside of a toilet paper? So that brown, that's pretty much what he's going to wrap the cling wrap around. Okay, his options are given in A and B. So he's got an option of using a board of that's got a diameter of 4 centimeters and a height of 30 centimeters. So diameter again is the width here, right? And the height is 30 centimeters. Here the width is 5 and the height is 20 centimeters. Okay, now we understand what's given. So 1.1 says, if he wraps the cling wrap around the board 35 times. So if he wraps cling wrap around this 35 times and the last wrap only 20%, so it doesn't go right around and only goes 20% of the way, calculate the area of each piece of cling wrap that needs to wrap around each option. Okay, so if I took option A and I took a piece of cling wrap and I wrapped it around here 35 times plus 20% extra, what would the total length of that cling wrap actually be? And they want to know that for both options. Okay, the formulas they give you here, they say the surface area of a cylinder is 2 times pi times radius squared plus pi times diameter times height, where pi is 3.142. Now, they like to do this in an exam situation. Okay, so take note here. We are only interested in where we're going to be wrapping the cling wrap around. So we essentially are only interested in the rectangle aspect of this cylinder. Okay, but what the formula they're giving you is they're giving you the area of the entire cylinder. Okay, so including the circles. So they expect you to know to leave this part out of the equation when you're actually answering this question. Because yes, this is the surface area of a cylinder. However, the question is only interested in the second part. Pi times diameter times height. Okay. So how would we then do this question? So if I look at A, okay, we'll look at, okay, the total width of A. Now, this is now actually trying to calculate the length of one rectangle, then multiplying that length, because it's going to go around 35 times. We're going to multiply that by 35, right? And then we're going to add 20% of that width. Okay, so remember, this is the formula for the circumference. Okay, so we're going to take this and we're going to multiply it by the width 35 times and then 20% of the extra piece. Okay, so that means if I substitute all my values in correctly, right, I will then end up with 442.3936 centimeters. Okay, so what do you notice I've done wrong here? What's missing here? The squared. Okay, so this needs to be centimeters squared. So no, sorry. No, the reason why this isn't centimeters squared is because what we've just done is, you see the rectangle we had, we just calculated the top part, which was the circumference, and we multiplied it by 35, which gave us the whole length. So that length alone is then 442.3936. Now I must multiply it by the height, because the area of this square rectangle around the cylinder, okay, the total of the cling wrap will then be that of the one cling wrap multiplied, that of the 35 cling wraps and the little bit multiplied by the 30, which is the height. So essentially this is length times breadth. Okay, length of the cling wrap times breadth of the cling wrap. Okay, so that will give us 13,271.81 centimeters squared. So this is the total width of the cling wrap. So it's the width of the diameter, the circumference, 35 times plus 20%, only a small piece added to that. When we substitute our formula, we get this. This will actually give our width of the cling wrap. The cling wrap, then to calculate the area, because the cling wrap is going to be a rectangle, is going to be the total area is then going to be this width multiplied by 30, because this is the height here, sorry, right? And that will give us 13,271 and 81 cents. And 81 centimeters squared. I don't know why I'm getting so confused with the units today. Okay, so now let's move to the total width of B. So again, circumference times 35 plus 20%. So same formula. Now I'm putting in my different values now in this case, right? My diameter is now changed from 4 and it's now 5. And the total width then of that cling wrap will be 552.992. Now to actually calculate the area of this cling wrap, it's going to be that 552.992, which is the width of the cling wrap, times the height, which is 20, which gives us the length times breadth, and that will give us 11,059.84 centimeters squared. So ideally, to wrap A around 35 times is going to use more cling wrap in terms of area than option B. Okay, I hope that makes sense. If it doesn't, go back, replay it for as many times as you need to make sure you understand this. Okay, so the concept that we are learning here is surface area. And this question is now taking what I showed you in the previous slide where we had the rectangle here. So this question is only interested in the surface area of this section here. It's not interested, it's not putting any cling wrap around the top parts, the circle. Okay, so that's how when I mentioned at the beginning where they can leave some surfaces out of a shape and you have to know where to take it off in your actual formula. Okay, so let's go to the next question. Okay, so the next question says, Chepo chooses option B, okay, and orders the cylinders from a manufacturer, right? So this is what he orders. The manufacturer packs the cylinders as shown below, right? Bird's eye view. Calculate the surface area of the box without the lid. Okay, so let's have a look at how they pack it. So this is the option B. Okay, this is the diameters, which is the from the one side of the circle through the center to the other side, which is double the radius. That is the diameter, and then the height is 20. So they're saying that this is how the manufacturer packs the boxes when they deliver this to them to be able to put the cling wrap around. So the question says, calculate the surface area of the box, right? So if this is how they pack it, you actually have to use the dimensions of the cylinder to be able to find out what is the total dimensions of the box. So if they packed this, you see there's only one cylinder in each box, like height-wise. Okay, so they're not packing cylinders on top of each other, and there are 6 cylinders next to each other. So if we were to calculate the dimensions of this box, now remember this is now a rectangle box. Okay, and I want to know what is the surface without the lid. So we are going to then calculate this area, right, based on the information. And then this is going to be front and back. And then there's left and right. And then there's only bottom and no top. Okay, so let's see how this calculation looks. So we're going to look at the base of the box first. Okay, do you see that if the diameter is 5, so from this side through the center to that side, that's 5. If I place these all perfectly next to each other, that means I've got 5 multiplied by 6. That means the width of this box, right? Or you can say the length of this box is 30 centimeters. Okay? Then the width, do you see they pack 3 here? So then that means that this part will then be 15. And the height is given as 20. Okay, so the area then of the base of the box, which means just the bottom part where we don't multiply by 2 because it's without the lid, that will give us an area of the length multiplied by the width, which is the 30 times the 15, and that gives us 450 centimeters squared. Remember, that is now just for the base. So let's look at the smaller side of the box, which is the left and the right part, right? So here you see it's 20, but what is this width here? Okay, so do you see this box actually has 3, there's 3 of these next to each other here, which is this 3 here. Okay, so the width will then be 3 times the 5, and that will give us 15 centimeters. So the area of the left and the right part will be 20, which is that, multiplied by 15, which is that, multiplied by 2, because I've got now this on the left and the right side, and it gives me 600. So what are we doing? We're calculating the area of all the surfaces except the lid. This part was the bottom part of the box. This part was the left and the right. And so we're only left with the front and the back now. Okay? So the larger rectangles will then be the length, which is then 6 fives. Okay, so 30. And then the width here is 20 because that's given. So the area of this is then 30 times 20. So 30 times 20, which is the area of this rectangle, and there's 2 of them, so multiply by 2, and my answer is 1,200 centimeters squared. Okay, so the total area is then the 450 plus the 600 plus the 1,200, and it will give us 2,250 centimeters squared. Okay, so that is how you will approach your surface areas questions. Once you understand the concept of surface, once you understand that it's only the outside sides of a three-dimensional shape, and that you understand the formula, and that you understand that in some questions certain surfaces can be excluded, and then you actually adapt your understanding of the formula and understanding of how to actually do the calculations, and you apply that understanding to the scenario that they give you. Because I've now given you an example of how you could use it, but in a test situation, they're going to literally give you anything. They can give you anything. And if you understand the formula, you understand the concept of surface area, then you shouldn't have any problems. Okay, I will encourage you that, when you are studying for this, go through my conversions video, make sure you know how to do that. Then you move to perimeter and area, make sure you understand area of a basic two-dimensional shape first, and then surface area, which is this video. Because those videos really complement each other to give you a holistic understanding of this work. Okay, I hope this video helped you and that you understand this a bit better. So that's that video. If you liked it, please give it a thumbs up. And if you have any questions, leave it in the comment section below. If you have any suggestions for future videos, also leave it in the comment section. This was literally a video I made because someone asked for it. So I really try my best to make sure that I give you guys what you need. Yeah, so thank you so much for watching, and I will see you in the next video. Bye.